In this video, we're going to talk about letters and envelopes. Let's get started. Letters A, B, and C belong to envelopes yellow, green, and blue. So A is in yellow, B is in green, and C is in blue. And for the sake of convenience, let's mark them as first, second, and third envelopes. So that's the correct order. The question is, when letters are arranged at random, find the probability that all letters end up in correct envelopes, all letters end up in incorrect envelopes, and at least one letter ends up in correct envelope. We have these three scenarios. We have to find the probability for all of them. Pause the video, give this a shot. Okay, let's do this together. So we have these three slots and we are arranging A, B, and C. We can arrange them amongst themselves in 3 factorial ways. So total arrangements are 3 factorial, that's 6. So we have 6 possible arrangements. Of these 6, there's exactly one that's correct. A first, then B, then C. This means there's only one way in which we can have all letters ending up in correct envelopes. Probability here, that's going to be 1 divided by total arrangements, that's 6. So probability here is 1 by 6. This one's more interesting. All letters end up in incorrect envelopes. So if you have to make sure that all letters end up in incorrect envelopes, let's start with this first one. This one has A, so we have to make sure that this does not get A. It can either get B or it can get C. Let's start with B. If this has B, the next one could be A or C. If it is A, the last one will be C, which means it's going to be correct. That's not something that we want. So we'll have B, then C, then A. In this way, we'll have all 3 letters in incorrect envelopes. We can also start with C. The second one can't be B because that's going to be correct. So second one has to be A and the last one has to be B. So B, C, A and C, A, B. These are the 2 ways in which we can have all letters ending up in incorrect envelopes. So there are 2 ways here. So the probability is going to be 2 upon 6, that's 1 by 3. And last one, at least one letter ends up in correct envelope. How do we figure this out? Well, we already have the probability for this one, all letters ending up in incorrect envelopes. We can just subtract this from 1 to get this one. So at least one letter ending up in correct, that's going to be 1 minus probability of all incorrect. That's 1 minus 1 by 3, that's going to be 2 by 3. But let's also list the possible scenarios. We want to make sure that at least one letter ends up in correct envelope. A, B, and C, that's correct. If we make sure that A is correct, we can flip B and C. That's going to be A, C, and B. This is also correct. We can start with C. The next one has to be B because we have to make sure that at least one is correct. So C, B, A, that's also having at least one letter ending up in correct envelope. We can also start with B. This has to be A so that this becomes C, which makes this last one correct. So these are the 4 scenarios where we're having at least one letter ending up in correct envelope. In the first one, we have all 3 correct. And for the remaining 3, we have exactly 1 correct. Let's take this one step further. Let's have 4 letters and 4 envelopes. Letters A, B, C, and D belong to envelopes yellow, green, blue, and orange. A, B, C, and D. For our convenience, let's mark this as the first envelope. This is the second one, third one, and fourth one. Alright, the question is, when letters are arranged at random, find the probability that all letters end up in correct envelopes and all letters end up in incorrect envelopes. Pause the video, give this a try. Okay, let's do this together. 4 letters in 4 envelopes. Total arrangements become 4 factorial, that's 24. If you have to make sure that all letters end up in correct envelopes, we can do this in only one way. We start with A, then B, then C, and then D. So A, B, C, D, that's the only possible arrangement. So the probability here is 1 by 24. The second one will need more work. All letters end up in incorrect envelopes. Let's start listing down the arrangements. We have to make sure that all letters end up in incorrect envelopes. So we can't begin with A. We can begin with B or C or D. Let's take this case. If it begins with B, the next one could be A, or it could be C, or it could be D. All 3 of them are incorrect. Let's take this first case. We have B, A, and we're left with C, D. If we make the next one C, this will make it correct, and we don't want it to be correct. So the next one is D, and last one is C. This way, all 4 of them are incorrectly labeled. Then we have B, C. We're left with A and D. This last one can't be D, so this third one has to be D and last one is A. So B, C, D, A also has all 4 incorrect. Then we have B, D, A and C. C can't be third, so A is here and C is at the last. B, D, A, C. Moving on, if we start with C, the next one can't be B. It could be A or it could be D. If we have C, A, we're left with B and D. The last one can't be D, so D is here and B is here. C, A, D, B, all incorrect. C, D, A and B are left. Both of them could be in any of these places. We could have C, D, A, B or C, D, B, A. In both these cases, we have all 4 letters in incorrect envelopes. Finally, when we start with D, the next one can't be B. It could be A or it could be C. If it's A, we're left with C and B. Third one can't be C, so that's B. Fourth one becomes C. In this case, if we have D and C, we're left with A and B. They can take any of these places. We can have DCAB or DCBA. So we have these 9 possible arrangements. There are 9 ways to have all letters in incorrect envelopes. The probability here, that's going to be 9 by 24, that's 3 by 8. The last scenario, at least one letter ends up in correct envelope. The probability of this is going to be 1 minus the probability that we have all letters ending up in incorrect envelopes. So this becomes 1 minus probability of all incorrect. This means 1 minus 3 by 8. This becomes 5 by 8. And these are the scenarios where we are having at least one letter ending up in a correct envelope.